we're going to conclude section 8.6 by looking at two applications for the dot product. Our first problem says a boat and trailer, which together weigh 650 pounds, are to be pulled up a boat ramp that has an incline of 30 degrees. What force is required to merely prevent the boat and the trailer from rolling down the ramp? Okay, so let's go ahead and let's see if we can draw a picture of what's happening. What I want to do is I want to determine two vectors. One vector is going to be formed simply by looking at the weight of the boat and the trailer and the fact that gravity is going to pull that boat and trailer straight down. So that vector is going to sit right here. So this would be the vector of having the boat and the trailer sitting right at the origin and not moving. And gravity would act upon it, and the force that would act on that boat and trailer would be equal to the weight. All right, so let's go ahead and let's write a vector representation for what is happening for that vector. Now that one is quite easy. Remember that we're going to look at the cosine of our angle. So our angle here is going to be 270 degrees. And the sine of our angle, and we're going to multiply that by the force or the magnitude, which is going to be 650. Okay, so I know that cosine of 270 is equal to 0, so I'm just going to kind of go in and simplify a little bit. Cosine 270 is equal to 0. Sine 270 is equal to -1, and I either have that memorized or I'm pulling that off of my chart for the different values for the trig functions. If I distribute my 650 through, I'm going to have 650 times 0, which is going to stay 0, 650 times -1, which is going to be -650. Okay, so this is going to be one of my two vectors. All right, and so that vector is going to represent the weight of the boat and the trailer, and it's going to be represented by the gravity pulling that boat and trailer straight down. Okay, so our other vector is going to be the boat ramp, and we know that the boat ramp has an incline of 30 degrees, so I'm going to kind of draw the boat ramp right in here, and I've got a 30-degree angle sitting right here. Now, I don't really know how long that boat ramp is, but again, I know that if my boat and my trailer are sitting right here at the origin, then I would be moving down that boat ramp. Okay, so again, let's make a representative determination for the vector in this case. So I'm going to say cosine. Now, what is my angle going to be? Remember, you're coming from starting position over here. So this is 180, we're going an additional 30, so we're at 210. And the other component's going to be sine 210. And we're going to multiply by our magnitude or our length. Now, we don't really know the length of this boat ramp, and it really can be anything. It doesn't necessarily matter at this point what value we use for the length. So what I'm going to do is I'm going to go ahead and work inside my vector for just a minute. Cosine 210 degrees is going to equal -√3/2. And sine 210 is going to equal -1/2. So really what I want to do here is use a magnitude or a length that is going to make my calculations a little bit easier to work with. So since both of these fractions have a denominator of 2, I think I'm going to use a 2 as my magnitude or my length. And then when I multiply that 2 through the bracket, those 2's are going to cancel out. And the vector then for my ramp is going to be -√3 and -1. Okay, so that is our first step, is to basically look at it, look at the situation, determine what we've got in terms of both of the vectors, and write a vector representation for each one. Okay, so now we're going to move on to the actual question, what they're asking me to do. And to do that, what I need to do is I need to do a projection vector and look at that projection vector formula that we've already talked about in the last section and calculate that projection vector. All right, so what I'm going to do is I'm going to give myself a little bit of room here. So I'm going to get rid of this. We'll leave our two vectors so we can see what we're doing. Okay, so remember that in order to calculate our projection vector, and actually I'm going to move this one down. Okay, so to do our projection vector, on the top part, we do the dot product of our two vectors. All right, so I'm going to multiply my initial components together. So for example, I'm going to do the negative square root of 3 times the 0. And that's just going to equal 0 for my dot product there. And then I'm going to add to that the second component. So the negative 1 times the negative 650. And that's going to give me a positive 650. All right, so my dot product is going to be 0 plus 650. And remember that on the bottom, we're going to do the magnitude of our vector squared. So we're going to take the magnitude of our vector, the ramp vector, and we're going to square it. So let's, off to the side somewhere, let's calculate that magnitude. Remember that the magnitude is going to be found by taking the first component and squaring, plus the second component and squaring. So we're going to have negative square root of 3 squared is going to be positive 3. And negative 1 squared is going to be 1. And so we have the square root of 4 as our magnitude. Okay, and remember that we need to square it in the formula. And so squaring the square root of 4 is just going to give me 4. And then I need to multiply on that original vector. All right, so let's do our calculation here. 650 divided by 4, let's see what that gives me. Gives me 162.5. And then we have it multiplied by our vector for the boat ramp. All right, so I have 162.5 on the square root of 3, and that will be negative. And I have negative 162.5 for my projection vector. Okay, so the last thing we need to do if we're calculating force is we need to calculate the magnitude of this projection vector. All right, and so let's go ahead and do that. Our last step, finding our magnitude, we're going to take our component. And this can get kind of messy because of the square root and what we're having to do here. And then we're going to take our second component and square it. All right, and so let's see what happens when we plug this in our calculator. So on that first component, this should give you 79,218.75. And the second one squared is going to give you 26,406.25. All right, adding those two together gives me the square root of 105,625. And taking the square root of that gives me 325. So if we have a force of 325 pounds, that is all we need in order to keep that boat and the trailer from rolling down the ramp. Okay, so again, just to sort of summarize what we have to do in a problem like this, we need to find a vector to represent each of the two forces. So one to represent the gravity and the weight of the object, and the other to represent the path that it's going to move in. Once we do that, we're going to do a projection vector for the two vectors that we have. And once we find that projection vector, we're going to then find the magnitude to find our new force. Okay, so let's move on to our second example. Our second example says a child pulls a wagon along a sidewalk, exerting a force of 15 pounds on the handle of the wagon. The handle is at an angle of 40 degrees to the horizon. If the child pulls the wagon a distance of 50 feet, what work has been done? So what we want to remember is that when we are calculating work, we can find work by taking the force and looking at the dot product with the distance. So given that formula, what I need to do is I need to write a vector for the force, and I need to write a vector for the distance. Okay, so let's work on doing that. All right, so let's begin with the distance, since that's going to be a little bit easier to handle. We know that our distance is going to be 50 feet, and she's going to pull that wagon at a distance of 50 feet. And so if the wagon sits at the origin and she pulls it 50 feet, I'm going to make my vector right here. All right, let's write our vector. So I'm going to look at the cosine of that angle, which would be the cosine of 0, and the sine of 0. And the force being acted on that will be the length or the magnitude, so that's going to be the 50. All right, I know that cosine at 0 degrees is going to equal 1, and sine at 0 degrees is going to equal 0. And so distributing my 50 through the vector, 50 times 1 is 50, 50 times 0 is 0. And so now we have our distance vector. Okay, let's look at our force vector. So she's going to pull it with the handle making a 40-degree angle. Okay, so our handle is going to come up like this way, making this 40-degree angle as she pulls. And so in doing that, we're going to have cosine 40 and sine 40. And we know that the force that she exerts on the handle of the wagon is 15. Now, this is not necessarily a very nice vector, but this is the vector for the force. So now we just need to distribute our 15. So I'm going to have 15 cosine 40 and 15 sine 40. And we're going to do the dot product of these two vectors, and we should have our answer. All right, so let's multiply our first two components together. So I'm going to do 15 times cosine 40, and I'm going to multiply it by the 50. And that's going to give me 574.5. And then I'm going to multiply 15 sine 40 times 0, which is just going to give me 0. All right, and so my dot product is going to end up being just 574.5, and work is measured in this case in terms of foot-pounds.